This is a video presentation of Chapter 8, Section 1 in the 8th grade textbook entitled Perimeter and Area of Rectangles and Parallelograms. So we're kind of starting anew here. We're now going to start looking at the two-dimensional and then the three-dimensional shapes, still along that geometric path, but really what we've studied are the different parts of the shapes and the different properties of the shapes and things we can do to shapes, and now we just need to study the shapes and their actual traits. So we'll start off with the perimeter and the area here, kind of a logical starting place. Remember, perimeter is the distance around the outside of a figure, and if it's a circle we would actually call something a little different. It's circumference, and remember it's called something a little bit different in a circle because it can't be physically measured with a ruler type device. It has to be calculated, but everything else is called the perimeter, which is again the distance around the outside of a figure. And the area is the number of square units in a figure. The number of square units in a figure. Okay, and with that out of the way, let's go ahead and jump into number 1 here. As you can see in number 1, we've got a couple different shapes here, and they're asking us to find the perimeter and of each of those figures. So what we're going to logically do here, instead of worrying about formulas, now notice here they do actually present a formula, but we're not going to worry about that so much, is we're just going to add up the sides. What's essential here is you have to remember, though, you have to add up all the sides. Some people look at this the type of question, they go, oh, 5 plus 14 and I'm done. Well, no, those are just the sides that have numbers, but all of the sides have to be accounted for. All 4 sides in this rectangle or quadrilateral, whatever you want me to say. So that means this is also 14, this is also 5. Of course, the top would match the bottom and the right would match the left. So this is 14 plus 14 plus 5 plus 5. That's the same as 28 plus 10, which is the equivalent of 38. And that's going to be given to us in units. The reason they say units there is because they didn't give us anything else. Meters, inches, feet. When they don't give us anything, we just say units. So it's 38 units around the rectangle. Now, in the second part, again, we're not going to worry too much about formulas, but what they say here is 2b plus 2h. They're saying you've got 2 bases and 2 heights, or if you want to think of it this way, 2 lengths and 2 widths, which indeed you do. You have 2 14s and 2 5s, and if we put that result together, you still end up with 38. Both are good options. All right, let's go ahead and take a look at the B question there. We've got that parallelogram there, another quadrilateral. It just happens to be a parallelogram. And again, we are finding the perimeter. And again, if you're saying 16 plus 20, well, you totally neglected the top and the right side. The top is the same as the bottom. The right is the same as the left. So the top is 20 and the right is 16. So I've got 16 plus 16 plus 20 plus 20 there. And when I add that up, that's the same as 32 plus 40, which is 72. 72 units. Again, just adding up the sides to find the perimeter here. That's all we're going to do. Not really anything too fancy about it. Okay, let's continue on with number 2. They're asking us to graph and find the area of the figure with the given vertices. -1, -2, 2, -2, 2, 3, and -1, 3. So the first thing we want to do is plot the vertices. Now, as you can see on mine, that's already drawn in for us, but we'll do it anyway. Remember, when we're plotting coordinate pairs, the first number always represents something on the x-axis. The second always represents something on the y-axis. And if you've forgotten, x is the one that goes left-right. Y is the one that goes up and down. So we've got -1, -2. That means from the origin, I'm going to go left to -1, and then down to -2 and put a point. For 2, -2, from the origin, that means I'm going to go right to 2 and down to -2 and put a point. And for 2, 3, that means from the origin, I'm going to go right 2 and up 3 and put a point. And finally, with -1, 3 from the origin, I'm going to go left 1 and up 3 and put a point. And I'm going to connect my points, and as you can see, we have our rectangle there. All right. So what's more important though now is we're supposed to find the area of the rectangle. Now there's a couple different approaches we can use here. when the shape is laid on top of the coordinate grid like that. What we can actually do is just count up the number of grid squares that are covered. Because remember, the area is the same as the number of square units needed to cover a shape. So how many ever squares the shape covers is equal to its area. And as you've seen, there's 3 boxes a row, and there's 5 rows, which means it must cover 15 grid boxes, which means the area must be 15. Now that won't always work though, because especially if it's a shape that doesn't lay perfectly over grid boxes, you'd be in trouble. And so then you would want to use the formula. Well, since this is a rectangle, let's use the formula for the rectangle. Rectangle base times height, or length times width, whatever you want to say. Well, this is 3 jumps here, 1, 2, 3, and this is 1, 2, 3, 4, 5 going down. So we're doing 3 times 5 there, 3 times 5, well, lo and behold, our answer proves to be the same. Either way, the answer is 15. Okay, so now they've taken what they call a composite figure, and they've drawn it on top of some grid boxes there, and we're supposed to figure out the area of the composite figure. Okay, so let's go ahead and look at what we've got here. A composite figure is just multiple figures put together. That's all it is. They put squares and rectangles and triangles and parts of circles together and whatever they want, and that's a composite figure. Now what's nice about this one is that that composite figure is laid on top of grid boxes, so we can kind of figure out from the grid boxes what the area should be about. As you can see here on the illustration that's on the screen, they've chopped this up into approximating it with some rectangles. They're saying this is about a 2 by 4 rectangle. Yes, there are some little corners there, but again, remember, we're estimating, so those little corners that we're not covering, not a big deal. And here, this is another smaller rectangle, and again, we're leaving off some little components, but again, we're estimating, so we're okay.